Okay, I guess now it's time to start. The doors are closing. Almost. Oh, it's open again. Okay. All right, let's get started. So first of all, welcome to this session. I hope Build has been a fantastic event for you. I hope you've learned something new in this event. You've made some more connections, and most of all, I hope you've had some fun, have some fun in the beautiful city of San Francisco. So my name is Haishi Bai. I'm a Windows Azure technical evangelist. This is actually my second year with Microsoft. Before I joined Microsoft, I've been working actually mostly in San Francisco and Mountain View for about 15 years. So although now I moved to Redmond, San Francisco still feels like a home to me. So I'm very glad to be back here, and I hope you've enjoyed the city as much as I do. So let me find my clicker. There. So today our topic is about patterns and practice for composing cloud services. This is a very large topic. So before we get started, I have to set some expectations. Because this is a very broad topic, it's not possible for us to cover everything within 1 hour. So instead, I will pick just a handful of patterns and practices you can use in your own projects. And because this is the last day of Build, you've seen all the new features, new announcements, and probably you already dived into different technical areas that you're interested in. So there's no new announcement in this session. There's nothing new. Everything is old. Everything is out there on the market. So don't expect I will say something new in this session. And this is another session about a parade of patterns. Like I said, I'm only going to talk about 3 or 4 patterns and practice in your projects. But the way we are organizing this session is this. Instead of just introducing one pattern after another, we'll go through a virtual project together. So today I'm going to walk you through a project that migrates existing on-premise line of business application to the cloud. So we'll do this project together. The project consists 8 sprints. We start with a pure on-premise application, and then we'll move everything to the cloud. I guess this is a typical scenario that you will probably face when you adopt Windows Azure in your own job. So I hope it can provide you some practical and useful information. But migrating this project is still too large to be fit into this talk. So in this session, I'm going through the first 4 sprints out of 8. And I will make the source code and the content available after the session. So if you're interested, you can finish the rest of the 4 sprints if you like. So let's get started. The starting point. Our starting point today is an on-premise application. It's a typical client-server application with a WCF service and a WPF client. The application relies on Windows authentication, meaning it relies on your Active Directory on your on-premise network. And the client is using MVVM pattern for separation of concerns. In the diagram, you see the system is using a local SQL database server. But what I'm using here is a mocked database. Basically, I'm using a file to mock this database. And let me switch to the machine to show you how the project looks like to begin with. So this is my Visual Studio 2012. This is not a new version. And you can see in this solution, I have my client project, which is a WPF client, and my server client, which is a console application hosting a WCF server. So what this application does is a simulation of work order management. Basically, the application allows you to enter and manage work orders, such as repaint your office, or water your plant in your office, or fix a lamp, things like that. So it's a very simple application. And let me just run it to show how it looks. So here you can see my server, which is a console application. It's waiting for my orders. And my client is coming up. somewhere here. This is a very simple WPF client. What I'm going to do is to create a new work order. And here you already see some problem. The requester name is supposed to be my user account. But the problem is that now I'm running this application outside our corp network. So I can't really authenticate against my domain controller. So this is why you see this unknown. This means I'm actually not authenticated to this client. We'll talk more about authentication in a moment. But at this point, I just want to point out I already turned off the security check. So here you can actually enter anything just for now. Let's say description. I want to add another bookshelf in my office. Then you see attached map. So I can place my order. You can see the client is calling the server through the WCF, and my order is placed. And after I created my order, I can actually upload the file as attachment to further explain what I need to be done. In this case, in my office, I want to have a third bookshelf to be placed right here. So that's the simple application. Everything is running on-premise. It's a client-server application. So now let's see what we want to do in the first sprint. So we've already seen the problem. This application is really designed for my on-premise network. It doesn't really work outside of the network because it relies on Active Directory. If I'm outside the network, I can't even authenticate to the program. Here, I hack the program so that I can continue, but this is really not a desired situation. So now let's assume that our company has heard about this Windows Azure website. Instead of managing a rich client, the idea is to have a Windows Azure website deployed somewhere so that my employees can submit work orders through a web interface. So this is the goal of our first sprint. Basically, we want to create a Windows Azure website. We want to have this web UI hosted on Windows Azure. Actually, this is a very typical scenario for a new project when you adopt Windows Azure. Because Windows Azure provides you this ability to quickly provision new resources, you don't need to plan ahead to allocate a lot of resources. Instead, you can just start with a simple website and go from there to see if this works. But to achieve this, there's a practical challenge. Let's say we've constructed this website, everything is okay, but on the other hand, we don't have time or budget to migrate our server. Of course, in my case, this WCF server is really, really simple, but in a lot of enterprises, you will have a very complex server that is really hard to be migrated to the cloud. So the first problem we need to solve is that how do we handle the connection between the website and my on-premise WCF server? Although logically this website is an extension to my existing system, but actually the problem we're facing here is an integration problem. Basically, we have a SaaS application on the cloud, and we have some legacy application on the on-premise network. How do we connect them? And in terms of integration, there are actually different strategies. And they can roughly categorized into 3 buckets. The first is to integrate at the data layer. And this is what we commonly seen in a lot of especially enterprise environment, such as shared data source, meaning multiple applications that actually share the same database or the same data source. Import-export, meaning one application exporting some data and got imported into another system. Or data sync, which means the application is still sharing the same data structure, but the physical data server are isolated, and they are synced through the data sync. So these are the 3 main ways we've seen to sync at the data layer. Of course, there are problems if you take this approach. All the 3 choices you've seen here, they have their own problems. For instance, the shared data source, it creates a very tight coupling among your system, which means all your system have to understand the exactly same database schema. And if the schema changes, it affects all the connected system. And import-export breaks this limitation. Basically, your applications can have different schemas, but the import-export often implies that this is a batch operation. This is not a real-time operation. And usually there are some manual steps involved to transfer the data in between. And data sync is kind of handle the import-export problem. Basically, you don't need to do this manual import-export anymore, but still your applications are sharing the same database schema. So those are the ways to integrate at the data layer. In my opinion, I would rather not to go there unless if I have to. The second part of the integration strategy is to solve the connectivity. My components cannot talk to each other because there's no connectivity between them. So I could directly solve this problem by providing some kind of connectivity among them. So the first one is the most straightforward one. One of my service will expose a public endpoint and for other systems to call into. And this seems simple, but in reality, it's really hard to achieve. Because when you do this, it usually means you need to expose a public endpoint from your corporate network. You may need to have a static IP address. You may have to provision your service into a separate network zone for security. So although this is a simple idea, but it's hard to realize. And the other way you can use is the Windows Azure Virtual Network. What the Windows Azure Virtual Network does is to allow you to allocate a segment of your on-premise network, and you can combine this network with your virtual network on Windows Azure through a site-to-site connection, so that the machines on this virtual network can talk and connect to each other as if they are on the same local network. So they can ping each other, they can use TCP to communicate each other. It's just like they're in the same network. And before, what we have for the virtual networks is that we require special hardware. You have to have the approved gateways in order to create this kind of connection. I think earlier in this year we announced that now you can have the pure software option as well. Basically, you can use pure software solution to create the site-to-site connection. And now we also have a point-to-site connection, which means on any laptop you can download a VPN client, and this laptop will be able to connect to your virtual network on Windows Azure. So that's one of the connectivity options. And the next one, actually this is the one we are going to talk about more today, is the Windows Azure Service Bus Relay. Windows Azure Service Bus Relay provides you the capability of exposing accessible endpoint without requiring you to change any network infrastructure. Which means, in my case, I can expose endpoint for my WCF service on this laptop. This laptop doesn't have a public IP address. This laptop doesn't have a static IP address. But I can still expose a stable relay endpoint for my clients to connect to. We'll talk a little more about Service Bus Relay in a moment. And the third part of the strategy is to use brokered things. I'm not saying brokered message, but typically what you see is first the middleware, like BizTalk. You've seen, if you've been in the keynote, you've seen our new BizTalk service offering as well. So basically, instead of all the components trying to connect directly to each other, they will connect through this middleman and communicate with each other. And the other important brokered pattern is to use message-based integration. Message-based integration patterns are really, really important. And this is not me saying. This is hundreds of people in the industry collectively saying in the past tens of years. And we will talk more about message-based integration in a moment. But here I have to clarify that if you want the Windows Azure Service Bus Relay, you can also put it in the third category because it provides a brokered connection. But that's just like a geeky point. If you want to categorize to the first, second one or third one, it doesn't really matter. And service bus relay. So this is like a 2-sentence, really a quick recap of service bus relay. Do everybody familiar with service bus relay? Show of hands. Okay, about 1/4 of people. So basically, what service bus relay provides is the ability for you to expose an endpoint and for other service to call you. And your service provider doesn't need to have a public or static IP address. And you don't need to change the firewall settings because usually you can only use the outbound port 80 connection or port 443 connection to connect to that endpoint. And once you expose this endpoint, any computers on anywhere in the world can connect to your service. Actually, this is what I'm going to show in the code demo. We'll actually enable the service bus relay between our on-premise WCF service and our website. So let me close this. And actually, I'm going to close everything. I'm going to fast forward to sprint 1. Excuse me. So this is my sprint 1. What I've done here is that my server and the client is still the same. Nothing changed. But you can see the order I just created. But now I've created a very ugly web frontend. This is version 1. It will get a little better over the sprint. And it literally has no features. And here you can see if I click a new order, I can say this is an online order. But of course, before I can do that, I have to connect this website to our WCF service. So let's do this. First, I need to modify my server. And this is actually an easy pattern, if you will, how to use Windows Azure services. So to use Windows Azure services, it's an easy 3-step. First, you get a NuGet package for the services you want to use. Then you change configuration. This is optional, actually. Then third, you just code it up. So in this case, I'm going to use service bus relay capability. So I'm going to add a reference to my Windows Azure Service Bus NuGet package. Just install, accept. Now I have all the necessary libraries for me to use the relayed connection. And before I change the settings, I'm going to open the app-config. And if you're familiar with WCF, this should be not too strange to you. Basically, I have two endpoint defined. One for my work order, the other is for my work order attachment. I created two separate endpoints because the attachment service, they use all the streamed binding to transfer the files. So what I'm going to do is to add new endpoints for my relay connections. So instead of typing, I'm just going to include the existing file to replace this guy. I have to change to file. Okay. Yes. Yes. You can see here I've created two endpoints for relay connection. And if you remember the ABCs of WCF service, the first, you need to check the address. You can see this is my relay endpoint I provisioned on Windows Azure Service Bus. And B is the binding. You can see here, instead of the basic HTTP binding or TCP binding, I'm using a relayed binding, which is provided by the Service Bus library. And the contract, ABC, the C, the contract is still the same. It's the same contract as I used in the existing service. So now my server is actually ready. So this is one thing I want to mention. Actually, this is so old, but I still want to repeat that. So the way to use WCF service is that you should always prefer configuration over the code. Because see, now I've extended my service and added new endpoints without ever touching my code. So this is a separation of a concern to separate your service implementation and your IT management. So my IT pro can actually go into my application and reconfigure my service to expose the relay endpoint without modifying the code. So that's my server is ready. So for the client, in this case is my website. I will follow the same easy steps. I will add a reference to my to Windows Azure Service Bus. Install. Close. Now my website is almost ready. Here I'm going to show you how I manage my work orders. Basically, everything is done in this API controller because I defined the API for my website. And in this website, I'm using a mock work order repository, which is based on a file. So in this case, I'm just going to create a new controller. A new repository to replace this mocked repository. So this is my WCF work order repository. And here, I just said you should prefer configuration over code, but here I'm showing the code just to explain how it's done. But this is not what you should do. So here I'm using a channel factory with my work order service. That's my contract, that's my binding, that's my address, ABC. Everything aligns up. And then I will just go back to my manage controller. Instead of using the mock repo, I will use my actual WCF service order repository. So now my client server, they are actually connected. And I can actually work on this. I will start everything, my client server. I will launch I will change this guy a little bit so you can see better. So here's my server running, here's my on-premise client. But here you can see I'm running this website locally on my computer. So this is kind of a cheating because everything is local. So to avoid confusion, let me close this guy. And I'm actually going to deploy this website to Windows Azure. So we are doing this for real. I'm going to import the website. And in case you missed in our keynote, this is a new feature of managing a website. You can actually list all your websites from your subscription. And if it loads. Do I still have the connection? Oh, yes. So I already have the website created. I'm just going to publish it. This will just take several seconds. So this website is being deployed to Windows Azure. We are actually running this on the cloud. And we are going to talk to this local laptop running my WCF service. So my website is there. My server is there. My on-premise client is here. Okay, now let's try to place an order. Say, this is an online order from Azure. I have to spell that right. Otherwise, I'll get fired. Okay. See, my order has been placed, but there's a problem of refreshing the page. Actually, this is one of the tasks in the future sprints. But here, I'm just going to refresh the page. You can see, hey, someone is placing orders. Okay, this is the unsecured website. That's the next sprint. We'll try to secure this website so no one can access this. That's my point. Okay, on the client, I can also refresh. You can see, oh, geez, I have to stop this now. Okay, see, that's why security is so important. Thank you guys for carrying over the points. Okay, now everything is shut down. Okay, that was fun. You guys are fast. Jesus, that never happened before. Okay. Now, that was fun. So now our client and server has connected over the relay. Okay, we've seen this demo. And just to recap what we've done. So the sprint one, after sprint one, we created this relay connection through Service Bus relay endpoint, and our server and our web client is connected. Now let's talk about the security. See, just you can see the website was open, everybody can log on, not log in, just go to the URL and place orders. But my challenge is actually more than that, because on the left side, I have my on-premise system, which relies on my Active Directory. Everything is okay. I can use my domain controller for authentication. I can query my directory using LDAP to retrieve attributes. Actually, what I didn't see is on the on-premise client, I'm also using LDAP to query my avatar from my Active Directory. But because I'm outside the network, the avatar really doesn't show. But I still have all those capabilities with me. But on the cloud, it's a totally different world. First of all, I don't have access to my Active Directory anymore. What I can do is to create a separate user store just for my web application. Like I create a simple user database that allows user to log in. But then I have the problem of the synchronization between the two user stores. My on-premise user has to remember a different site of user ID and the password. And if one of my on-premise user got deprovisioned from my Active Directory, I want to disallow them to access my website as well. But this kind of synchronization is kind of hard to do. And if you know about Windows Azure, you probably know what I'm going with this. This is what Windows Azure Active Directory solves. And basically, it provides you the capability to authenticate your on-cloud applications. It provides you a single sign-on capability, not only among your own applications, but with millions of users who has been using Windows Azure Active Directory as well. For instance, all the Office 365 users, they are actually using Windows Azure Active Directory for authentication. So if your application uses the same mechanism, you can potentially provide single sign-on experience to the huge tens of millions of user base. And it also provides a Graph API, which is roughly equivalent to the LDAP queries you can do on a local Active Directory. Basically, you can query user attributes, you can query relations between them. And also, last but not least, it provides you a built-in capability of synchronizing with your on-premise AD. By installing a directory sync agent, you can actually sync up your selected users and groups up to your Windows Azure tenant. So there are a lot more to talk about this service, but here I'm just going to show you a simple animation trying to explain how that works in a typical application. So the first step is to create a trust relationship between your application and the Windows Azure tenant. The trust relationship has to be two-way, has to be explicit, which means your application has to explicitly trust Windows Azure Active Directory as your identity provider, and your Windows Azure Active Directory tenant has to explicitly trust your application as a reliant party. Actually, here brings one of the key takeaway points I want to mention in terms of practices. Sorry, I have to drink. I have had some very spicy food for lunch, which is a mistake. So I've seen many projects involving configuring Windows Azure Active Directory, and many projects fail miserably, and many other projects worked very well. And there's a key difference between these two types of projects. Because we have to establish this very explicit trust relationship, that means everything has to match. Everything has to match perfectly. The certificates have to check out, the bindings have to be right, the encryption key has to be synced, everything has to be aligned. The key way of tackling this kind of problem is actually simple. It's just to take a systematic approach. Start with nothing configured. Make sure your server and the client can connect to each other without Active Directory. Then do one step at a time. For instance, you can enable transportation security first, then you enable message level security first, then you add token encryption, then you add custom claim size. So just do it one step at a time. It sounds simple, but if you ever get involved in such a project, this is very important. Take steps to complete a very complex scenario. So after you configure this kind of a trust relationship, once a user tries to log on to your system, and the WIF, Windows Identity Foundation module, which is injected into your ASP pipeline, will intercept the call and check to see if the user has been authenticated. If not, it will redirect you to Windows Azure Active Directory for sign-on process. The Windows Azure Active Directory will provide you a login page. You authenticate over there. Then your tenant will return you a token. So this is a security token contains claims about you, basically contains your attributes, like your name, your role, your groups, etc. Then you request access to the application again with this token, and this time WIF will see you are already authenticated, and it will grant you access to the application. How the single sign-on works is that when you provision multiple applications to the same tenant, essentially you're creating this circle of trust. Because both applications trust the same type of token from the same tenant, potentially you can provide this single sign-on experience across applications. And the last but not least, you can use Directory Sync to sync your on-premise AD to your Windows Azure Active Directory tenant. And for this one, I'm going to show a demo. This is a very brief demo because we are actually running low on time. Let me switch back to the machine. I need to close this guy. I should have brought 4 machines with me. So demo, open this. So I'm fast forwarding again. This is a Spring 2. And in this, actually, I'm just going to directly to do it to save some time. So like I mentioned, you need to configure this two-way trust relation. First, let me show you how do you configure that on the Windows Azure management portal. And if you remember what you saw on the keynote in Visual Studio 2013, we have a newer, better tool of doing this. But here I'm just showing you a little more steps on purpose, so you can see how this configuration relationships are established. So on the Active Directory side, I can open up my tenant. And you can see here's a list of my applications I already configured that my tenant will trust. Oh, Thai food. So this is one of my applications. You can see that it's trusting my localhost 9506 application. So I'm already done with this part. And if I open the details of this configuration, you can see we also provide the WS Federation metadata file. If you don't know this, basically it's a metadata file that helps you to auto-configure the trust relationships. So I'm just going to copy this URL and go back to my website. I'm going to right-click and use Identity and Access tool. Again, this is not the brand new tool. This is the Identity and Access extension to Visual Studio 2012 that you can download. I'm just going to select it. And I'm going to use my ADFS or Windows Azure Active Directory tenant this time. I'll paste in my metadata. I'll say, OK. There's a lot of things going on under the hood, but that's all you need to do from a developer's perspective. Let's try to launch this again. You can see the website is being launched. But because of the trust relationship, I'm redirected to my identity provider, in this case, Windows Azure Active Directory, to sign on. I'll log into my tenant. And what's my password? Okay, now I challenge you to create another work order. Oh, okay. No, the challenge is invalid because the website on the Windows Edge is still open. Okay, this is my local website. Okay. I knew I shouldn't have said that. Okay. Okay, but you've seen that this is really easy to protect your website using Windows Azure Active Directory. But that's not the complete story yet. If I show you the code, open the server. Open my website, controller, my .co controller. You can see here, when I connect to the service bus endpoint, the service bus endpoint is protected by Windows Azure Access Control Service, which requires me to provide the security token. And in this case, I'm actually using a fixed user ID and a password to authenticate with service bus. So this is not really a valid scenario because what I want to use is my user credential, not user credential, but my user information from Active Directory, and I will pass that through to my backend service. So this is a very typical scenario that you have a front end, which is protected by some kind of mechanism, but you want to carry that security context all the way through different layers to your backend service. But unfortunately, I'm not going to show that part today for three good reasons. The one, we are really running low on time because I want to show you some other things. The second, the code is not as beautiful as I'd like. But I forgot the third reason. But yeah. But you're welcome to connect with me afterwards. We can discuss more because it's actually rather complicated to explain how that's done. Because imagine when your Active Directory issue a token, it's issuing a token to your website. It doesn't know about your backend, your backend service. So what you need to do is to do some kind of act as behavior that you can use the token to exchange for another token that your backend service can understand and use. So this is actually not trivial to do at this point, but I'm glad to share with you my code afterwards if you come to me. So that's the Windows Azure Active Directory, and because I have two machines, I can just switch back. And let's just recap what we've done on the Sprint 2. On Sprint 2, we add a Windows Azure Active Directory to secure our website. We'd like to carry through our security context, but we haven't done that yet. But now we have a problem. The problem comes right now. So before we move forward, something happened. Actually, I will just show you how that looks. I'm going to switch back to, I'll just stay on the page for a while. Let me set it up before I switch back. Okay, 8. Okay, here, let me show you again. Excuse me, what it means. So I believe here, I turn off security on this one again. And there's an exception. That's unintentional because I think I changed too much. Let me just delete my temp files. I think there's a cached JavaScript that's causing a version mismatch. So anyway, this should work. I have my server. I have my website. See, now my website actually, this is Sprint 3 already. I've done some minor improvement. Now it's showing description as well as details. So I can place a new order. Here say this is another order. This is fine. I've placed the order. You can see it went through to the WCF service and it came back on my web page. And now what happens is that because my website is hosted on Windows Azure website, which provides me a highly available and highly scalable hosting environment, so I can pretty much be sure that my website will be available and online. But what happens is that my on-premise system, it doesn't have such infrastructural support. It's just running on my local laptop. There's no high availability configured, and my server just crashed like that. And now if I want to place a new order, this is a new order, some text. And you can easily expect my website will actually crash because the server is gone. I'm using a relayed connection to my backend server, and the server is not there. So how do we deal with this? I mean, this is one of the another key points. When you create a new SaaS application that relies on your on-premise system, the way you deliver a SaaS application is that you usually need to promise or sign the service level agreement with your customer because you are not selling a software anymore, you are selling a service. And usually this service is bound to some kind of SLAs that you have to honor. But if you have a dependency on your on-premise system, and how do you ensure you can deliver that SLA without being affected by the on-premise environment? So in this one, I'm going to talk about a very important pattern, which is the loose coupling. This is not new. I mean, like I said in the beginning, this is nothing new in this session. But the loose coupling session, what it means is that it creates a buffer between your on-premise system and your online system, so that if your on-premise system fails, it doesn't affect your online system. And we can easily do this through a service bus queue, which means instead of the two components trying to communicate with each other, my website will put a new work order into a queue, and my WCF service on-premise can pick up this queue at a later time. So in this way, if my service on-premise crashed, it doesn't affect my website because from my website's perspective, all I want to do is to place the order in a queue. So let me show you the Spring 3, how do we deal with this. Let me close this. First, let's modify the server side. So the server side, I'm saying instead of waiting for a relayed connection, I'm just going to get my new orders through a queue. I will add a new class. No, see, when I say I add a new class, I mean to add an existing class. I have this order taker. I'll show you how it works. So here you can see this is a service bus library class. You can use queue client to connect to a queue. Then you just keep looping, and when you get a new message, you just call the repository to place the order. And this is actually something new I want to show you here. This is still not brand new, but kind of new. So you can see when you use service bus or use any other queuing services, usually you need to do this kind of a loop, to loop through the queues to pick for the messages. And each pick for the messages, actually that's a chargeable transaction to you. What we provide in the updated service bus library is to support this event-driven programming model, so that you can actually create a queue, then wait for the message. For instance, queue client, you can say on message, then you provide a callback. And there's another option which I'm not going to go into details here. I'll just say here. So basically, you can wait for this on-message event, and in this event callback, you can just, let's say, body equals get body. You can read your message and complete the message as before. But this provides you a very easy event-driven programming mode, especially when you're writing the client-side code, like a WPF client or HTML client. You can use this kind of event-driven because it fits pretty well in the normal client programming model. But here I'm just going to delete this guy. I'm old-fashioned. Okay. I think the server is almost ready. I have my order taker. Now I just need to create a new instance for this guy. Order taker. Oh, now work taker. Order taker. Taker equals no. And I need to pass in a connection string. Bear with me for a moment. Configuration manager. I lost my ability of typing. And I forgot what my connection string looks like. And I need to copy this guy. Apologize, I should have pasted this in. So I get my connection string and my queue name, which I believe is order queue. And my taker will start to take orders. And once my host closes, I will close my taker as well. So that's fairly easy. Basically, I'm just starting a new listener to my job queue and listen to the job. And on the server side, remember we have this abstraction of repositories. So all I need to do is to introduce yet another repository. Spring 3, I said queue. I'll show you what it does. This is fairly simple. I'm using the same queue client connected to the same queue. I'm just generating orders to this queue. And back to my API controller. Instead of a WCF version, here I'm going to use the queued version. Queue work order repository. Okay, I believe it's ready. Let's give it a try. It's compiling, my server is up. My website is starting. I don't think I'm starting the client. So this guy, I'm going to create another one. So this is the, fifth order? Maybe. Okay, this works fine. And now my service crashes as planned. And say this is an order while you were asleep. Wake up and do something. See, my website kind of worked. It didn't crash. That's a good point. But here I'm losing all my order list. This is an issue we are going to address in the next iteration. But the point is that my website is not affected by the fact that my service is gone. And what happens later if I restart this server? Start a new instance. And you can see my taker already detected there's a pending job for me to do. So the taker will take the job and put it in my order repository. Then you can see my order is created here. So this is actually quite, significant, if you will. You can think, say, in this way, I'm actually decoupling my SaaS application with my on-premise system, which doesn't have any support for high availability, scalability, or reliability. But still, I can achieve higher level of SLA using this loose coupling. And there's more to this. Let's imagine that this work order management really takes off. It has tens of millions of users. And what if my single instance on my on-premise system can't handle that workload? Now, because of this loose coupling, I can actually start multiple instances as I will. I mean, I can just simply start 10 or 100 instances on my on-premise network, and because they are all subscribing to the same job queue, essentially they form this pattern, what we call a competing consumer pattern, which means I can actually scale out my on-premise system without any infrastructural support. If you think about that, that's actually quite significant, because you can actually achieve this level of flexibility and scalability just by using a job queue in between of your front end and your back end. And let's go back to the slides. Okay, I think we're going to do this. I'm going to skip this because we're running low on time. And let's just recap what we've done in this sprint. We created a job queue in between our website and our backend services. So we decouple these two parts, and we can scale out each of the components separately without affecting each other. And now there's another story. Actually, this is the last sprint we're going to do here today. So now we are in this world of cloud plus devices. And I've seen that in a lot of enterprises, there's more and more, not only just mobile phones and tablets, but other sensors and the devices got integrated with your enterprise solutions. So in this case, in this fictional case, my company purchased some sensors that can monitor my office environment and automatically generate some work orders. For instance, I can have a sensor in my office to detect if the light goes out, so it generates a work order to replace the light. Or I can have a sensor in the, let's say, bathroom to detect if there's an overflow, then it will generate an urgent order to get that fixed. But the challenge of that is that a lot of those devices, they run on their own embedded system. They usually don't know about Windows Azure. They don't care if you're using Service Bus or Relay. They just talk common protocols, use a very simple like a RESTful calls. So here I'm going to show you a little example how to include those kind of devices and third-party systems by using standard protocols. So in this demo, I'm going to show you the AMQP protocol support by Windows Azure Service Bus. Basically, now we allow you to connect to our Service Bus queues through AMQP protocol. If you are not familiar with AMQP, it's an open standard for message exchange among systems. It defines the wired level protocol so that different systems implemented using different technologies can securely and safely exchange message to each other. And just to make the point, here I'm going to switch back to my Visual Studio. And I'm going to use Java in this time. Any Java developers in the audience? 1, 2, 3? Okay, good. See, myself, I was a Java developer for about 2 years. Actually, I was involved in writing the JDBC driver for Crystal Report. But the language, the problem with language is that if you don't use the language, it kind of fades away. But now I'm picking it up because we have this new partnership with Oracle. You can imagine the Java is getting more tractions. Okay. So because there's a very few Java developers, I won't go into the details. Basically, I'm using JNDI to resolve my Service Bus connection. But the point I'm going to make is here, if you see the reference, the libraries or the imports I'm using in this Java program, I'm not using any Azure stuff. This is the Qubit library from Apache. This is all open source. So I'm not using any Windows Azure specific stuff, but we do have a Java SDK if you want to use. So the code is actually simple. After I create a connection, I'm just going to construct a message and set the properties and send it over. And I believe my server is still running. Just run this. We'll go to this is an order from Java. Java is cool 2, I guess. Okay, now the order is sent. Let me see if the server receives it. And you can see the server, because it's subscribing to the same queue, it gets the order. But there's something very interesting to show here. I extended my system while my system is running. Right? I didn't shut down my server. My server is running. I believe my web client, if I didn't turn it off. My web client is running as well. So in a lot of situations, you have a critical, mission-critical system on your on-premise. you cannot afford to shut it down or make significant modifications. But by the loose coupling, you can actually extend existing system while your existing systems are still in the running state. So this is something you can think about in a scenario like this. So I think we only have 1 minute, and we have 4 more sprints. Let's see if we can do this. Okay. Sprint 4, that's what we did. We used the AMQP to talk to our queue and manage message-based integration patterns. There are tons of them, hundreds of them. I encourage you to look into them. Basically, it covers most commonly seen scenarios you may face in the integration world. And Sprint 5, what the plan was to use cache, because for now, our website goes back to our WCF service every time it refreshes the pages. The idea is to use Windows Azure caching to cache the data locally so that we don't need to go back every time to our backend service. And we'll, for the attachment, instead of streaming all the attachment back to the server, we'll put them in the Windows Azure blob storage and use CDN to speed up content delivery. The point of Sprint 5 is actually Windows Azure. This is a consistent message from the beginning of Windows Azure. To use Windows Azure, we are not saying you should move everything to the cloud. That's just impractical. We acknowledge enterprise is made of hundreds of applications. What we've been saying from the beginning is that we want you to use the cloud. We want to use the capability when it makes sense to you. So in this way, you can get the max benefit without incurring a lot of risk. And Sprint 6, that's when we have the loose coupling. It doesn't matter where our server runs anymore. So we can actually start a virtual machine to get our server migrated to the cloud. And if we have multiple instances on the cloud and on-premise, we'll use data sync to sync among the servers. And then eventually at Sprint 7, we are ready to get rid of the server altogether. So everything will be on the cloud, will be scalable. Then in Sprint 8, we'll do the integration. We'll do integration through BaseTalk to your on-premise accounting or ERP system, and we'll use the Office APIs to integrate with Office applications. But that's the plan for the future, or maybe some next talk. I think I have 40 seconds. And there's a secret I want to reveal. I said there's no announcement, but there's a little secret announcement. So you can see this application from the beginning to Sprint 4, the architecture of this application has changed significantly. From a client-server application to a web application, and we have all those loose coupling capability. So this application is designed to be changed at the beginning. And the way we designed this application is to use the recipe VVM pattern. Don't Google it. It's not public. It's still work in progress. We do have a white paper on this. So if you are interested in this kind of work, this is still early stage. But if you want to have a deeper study or work on this kind of a pattern, you're welcome to get connected with me, and we can make something useful. And with that, I give us some resource. The Bing, of course, you can search anything. Windows Azure, and my handles. Thank you very much.